Hi, this is Mrs McTaggart, and in this video we're going to be looking at multiplying fractions. And this topic actually falls under National 5 and 4th level. So before I start multiplying fractions, I just need to do a quick recap that you know how to do mixed fractions into improper. Now you should have seen this before, and you should also be aware of how to add and subtract fractions prior to this. To turn mixed to improper, we were basically trying to think how many quarters there would be altogether if we had 4 1/4, let's say, cakes in front of us. So what we do is we do the big 4 times the 4 on the bottom, and then we add the top number, which is a 1, and that becomes how many fourths we've got, or how many quarters. So we've really got 16 plus 1, which is 17 quarters. And then the little kind of mantra I use is up here in the top corner. I use the phrase big times the bottom, add on the top, and it always gives pupils a bit of a giggle because I say big bottom. Okay, the next one, so we're going to do the big 5 times the bottom 3, so we're doing 5 times 3, add on the 2, and it all turns into thirds. So we would have 15 thirds plus the other 2 would be 17 thirds, and it's a big chance I've got 17 again, it's not always 17. And for my last one, we'll do 3 times 8, add on the 7, which is 24 plus 7, which is 31 all over 8. And you don't always have to write what I've been doing at the top. So that was just a quick recap. So let's go on to multiplying fractions. So I'm going to start with a very simple example to try and illustrate why we do what we do in multiplying fractions. So here's my sum here of a half times a half. Now when you've got half times a half, that's me effectively cutting this pink half into half again. So this bit here is what would be left, and that is a quarter. So we can visibly see that half of a half equals 1/4. Now, what's actually happening here is we're doing 1 times 1, and we're doing 2 times 2, and we're getting the answer of 1/4. But just to prove it with other numbers, here's another one, half of 5/6. So I'm going to half all of these. So I'm going to take half of that one. I'm going to take half of this 6th. I'm going to take half of this 6th, half of this 6th, and the same again. Now I'm going to half this one here just for visual sakes, but we're not taking any of those ones because that wasn't there. So if you count what I've shaded in, I have got 1, 2, 3, 4, 5 bits shaded in out of a possible 12 because I've turned those 6ths into 12ths. So the answer is 5/12. And if you look at the sum again, 1 times 5 is 5 and 2 times 6 is 12. So the rule really is that we're just multiplying straight across, top times top, bottom times bottom. So here is what the rules would be, and this is what I'd get you to write down as a little note. So the rules are they always make them top heavy first. You do not multiply the whole numbers. They have to be top heavy, or proper, I should be really saying improper fractions. The method we use is top times top and bottom times bottom. Or there's this other little method where we can cancel diagonally, and I call them karate chops sometimes. And you can only do that sometimes. You couldn't do it in any of those two I've just used. So I'm going to show you the two methods. So here is my first example. 5/6 times 3/8. So using the rule we've just been doing, well, that would be 5 times 3 on the top, which is 15, and 6 times 8 on the bottom, which is 48. But at a quick glance, you hopefully spot that they can simplify. You need to always check that fractions simplify to get full marks. Now these are both in the 3 times table, so I'm going to divide both of these numbers by 3, and I get 5/16. Now 48 isn't obvious as being in the 3 times table, but I know that 3 times 15 is 45. That's only 3 more, so I know it's divisible. Now there is another way. I mentioned these karate chops. So what happens is, in a sum, if you can see numbers diagonally, for example the 3 and the 6, that have something in common, we can cancel them out. So what we can do is we can score out the 3 and say, right, well 3 divided by 3 is 1. And we can score out the 6 and say 6 divided by 3 is 2. And the sum becomes 5 times 1 and 2 times 8. And then that gives you the 5/16, just ever so slightly quicker. And it really helps when you come to do fractions with big numbers that are too hard to multiply. Let's say you're not a fan of long multiplication, or even just multiplying a 2-digit number by a single. The karate chops or the cancelling diagonally trick definitely helps. So let's look at this one. So we'll do it both methods again. So 7 times 4 gives us 28. 9 times 5 gives us 45. Now this doesn't simplify. The only things that go into 28 are 4 and 7, 2 and 14, and 1 and 28, none of which go into 45. And actually, because there was no kind of cancelling diagonal options there, I know that that won't fully simplify anymore at all. So that's that one completely done. So it's not always possible to do the cross cancelling. So what happens next to make it a little bit harder? What do? We make it mixed fractions. So step 1 was to make them top heavy. So the big number times the bottom, 1 times 2 is 2, add 1 is 3. So I've got 3 halves, times 2 times 3 is 6, add on the 1 is 7. So I've got 7 over 3. Now if I just do it top times top, I get 3 times 7 is 21, 2 times 3 is 6. And then I should hopefully spot that's my 3 times table, so I'm going to divide both of these numbers by 3, and it gives me 7 over 2. Now to use a karate chop method again, here's a 3, and here's a 3, so I divide them both by 3 and get 1, and that just gives me 1 times 7 is 7, 2 times 1 is 2. Both get me the same answer, but one has a heck of a lot less working than the other. And my final example, let's do one more. We're going to make them top heavy first. So top heavy, big times the bottom. 5 times 3 is 15. Add 2 is 17. So I have 17 over 3. Times 4 times 1, or 1 times 4 is 4. Add on the 1 is 5. So I've got 5 over 4. Doesn't look like anything's going to cancel on this one diagonally again, so I can't do any of the karate chops. I just have to do good old top times top, or bottom times bottom. Bottom is easier, so I'll do it first. It's 12. I'm left with 5 times 17. You can either try it mentally, or remember there is absolutely no shame in going to the side and doing a little sum. And 5 sevens are 35, 5 ones are 5, plus the 3 is 8. And it leaves me 85 over 12. Now you might have noticed in all my examples I have not converted them back to mixed fractions. My number one tip is why bother, okay? In an exam, it doesn't ask you. They're generally just happy for you to leave it top heavy. But what you don't want to do is convert it incorrectly and then lose the chance of possibly gaining full marks because you've gone on and done something wrong. So that's the end of this video. I hope this has helped. Thanks very much for watching. Bye bye.